What in the heck is going on with this one? We have subtraction. We got fractions. In fractions. My goodness, this looks like a boatload of fun. All right, so what the heck do we need to do? I'm going to deal with my numerator and denominator separately. Let's get them into one fraction, okay? Because if I have a situation where I have like this, where I have a fraction over a fraction, I can then multiply by the reciprocal as we did with dividing rationals, okay? So let's see if we can do that. Well, in order to get my numerator as a single fraction, I'm going to need to multiply the 1 by x over x, okay? Because this 1 right here is really like 1 over 1. So to get that denominator to be the same, I need to multiply by x. All right, so now what I'm going to have is I'm going to have 2 over x minus x over x, okay? My denominator here, I'm going to have to multiply this one by x over x, but this one by y over y to get them to match up. So now I'm going to have x over xy minus 3y over xy. All right. So now I have matching denominators in my numerator and in my denominator. Let's do that. Okay. So I have 2 minus x over x divided by, we have x minus 3y over xy. So now I have the complex fraction situation where I can go ahead and I can just multiply by my reciprocal, right? So what I'll have is then 2 minus x over x multiplied by, this will be xy over x minus 3y. Okay, can I simplify? Yes. So the one thing that I can do here is I can cancel out these x's because that's multiplication is how it's joined. It's x multiplied by y. This 2 minus x is multiplied to that x. This x minus 3 is multiplied to by that x. So those x's are free to cancel. These, however, are not free to cancel because they are tied to that 3y with subtraction. They're tied to that 2 with subtraction. So those would have to stay as is. So my final answer here will be y times 2 minus x divided by x minus 3y. Dunzo. That was dope.